What's up, guys? Here we are back again. I'm going to give y'all another little engine 101. This is going to basically be over electronic fuel injection and how it kind of functions in our modern high-performance cars. I'm going to talk a little bit about the closed loop and open loop. Also got some air-fuel ratio stuff up on here, but I don't want to make the video too long, so I might kind of split it into a two-part. So we'll go ahead and get started here. First, we'll go ahead and get started. I'll talk about the differences between the closed loop and the open loop system. EFI basically functions in these two systems, and it switches back and forth. Our first basically system was gonna, I'll go ahead and talk about it. It's gonna be our open loop. And the open loop is gonna basically be our first system because this is what the car is gonna be running in when we crank it up in the morning and you have a cold start and you get that awesome sound from the exhaust. Basically, open loop is when the engine is not at a operating temperature, and open loop is used on startup, cold start. It's used before the engine's at operating temperature. It is used at wide open throttle, which is one of our favorite places for the motor to be. Basically, your fuel and spark tables and your RPM tables is set in your ECU for the open loop. Comes down to your outputs, which is basically your fuel injectors and your ignition, and then that is input into your motor. And what it does, it uses set fuel and spark tables, takes no O2 sensor feedback, and is basically the first system that we want to tune in. If you're taking it to a tuner, engine tuners will you generally tune in open loop first, and you're going to start out at 1500 RPM, around 2000 RPM and up. So say like we're on the engine dyno, and we're tuning the car on the dyno, and you would really want to start there. You want to start within the widest RPM band and try to get those fuel and spark and spark tables set in that big wide range. And then once we have those dialed in, then we can go in and we can set the actual the idle. Can be done, because idle is pretty difficult to actually tune, and this is all tuned usually using wideband O2 sensors, so they can measure air-fuel ratio and set that to basically in your fuel tables. You'll have basically a bump up every 50 or 100 RPMs. It'll bump up, and you'll have different tables where you can set the fuel and spark to actually tune for max power. And what they can do is, on the dyno, tuners can actually hold the car in open loop by going into the computer and adjusting the engine coolant temp sensor to a maximum range level, where the car will basically never reach operating temp, and it will stay in open loop. Now, once the car reaches operating temp and we come out of wide open throttle, the car is going to get forced into what we call closed loop. And closed loop is basically the area where the fuel injection shines. Now, what this area is it's when the engine's warmed up, and it's going to take the inputs from all your sensors. So your throttle position sensor, your map sensor, your intake air temperature, your O2 sensors, all this stuff is going to be basically calculating inputs, and it's going to go into the computer, and the computer's going to adjust, tell our fuel injectors and the ignition timing what to do, come back around to the motor, and it's basically going to keep the motor at the most efficient air-fuel ratio that the OEM manufacturer has it set to. And that's usually going to be a 14.7 to 1 air-fuel ratio. So it's 14.7 parts of air to 1 part of fuel. And that is basically for our EFI. So when we're driving at sea level, or if we're above sea level, or if we're if we're up in the mountains, if it's winter time, if it's summertime, you know, all the different varying closed throttle, half throttle, you know, various different adjustments. It's gonna basically adjust on the fly, and it's usually, you know, used from low to mid speed cruise. Reads inputs from your the motor sensors and adjusts to the target air-fuel ratio that the OEM manufacturers have set. And this is the fuel ratio for gasoline that gives the motor the best combustion and the best emissions. Once fuel and spark tables have been set in open loop, very little adjustment should be made in closed loop. And what that is going to give us is that's going to give us a car that, you know, has a really good horsepower at wide open throttle. And when it goes into closed loop, we're still going to have a very efficient motor that gets decent gas mileage too. So that is basically the way of EFI, where we can have the best of both worlds, as opposed to guys running carbureted motors that, you know, have to make jet changes, you know, per the different altitudes and the temperatures that they run. That's definitely one place where EFI shines. So that's it, guys. I'll talk upon basically the more about air fuel ratios next time. I'll check y'all guys later.